This is number 4 from the 2011 exam. Okay, so we have this continuous function on our interval -4 to 3 that consists of 2 quarter circles and 1 line segment. And we're also given that g of x is 2x plus the integral from 0 to x of f of t. So part A, we need to find g of -3. So that would be 2 times -3 plus the integral from 0 to -3 of f of t dt. So this is -6. And I'm going to change my limits here. So we've got -6 minus. So the integral of f of x, of f of t, from -3 to 0. So we're going from -3 to 0. So we want the area of this quarter circle. So that would be 1/4 of pi r squared, and r looks like it is 3 units. So we get -6 minus 9 pi over 4. Okay, still not done with part A. We need to find g prime of x. So g prime is equal to, the derivative of 2x is 2, plus, and now this is our second fundamental theorem. We want the derivative of this integral, which gives us f of x. And now we have to find g prime of -3. So g prime of -3 is equal to 2 plus f of -3. So 2 plus f of -3. This is f. Here's -3. So f of -3 is 0. Okay, part B. Determine the x-coordinate of the point at which g has an absolute maximum. So it would be good to start off by finding some critical numbers, and that happens when g prime is equal to 0. So that's when 2 plus f of x is equal to 0, or when f of x is equal to -2. So when does that happen? When is f of x equal to -2? So it looks like right over here. And we'd really like to know that x value now, wouldn't we? So we know that the equation of this segment is y minus, oh, I don't mean minus, let's do y equals, the slope is -2, because to get from this point to this point, we'd have to go down 6 units, to the right 3 units, so that's a slope of -2x, and our y-intercept is 3. So now we want to know when f of x is equal to -2, subtract 3 from both sides, so that happens when x is 5/2. So back down here, f of x is equal to -2 when x is 5/2. So now it would be good to know what's happening with g of x on the interval from -4 to 5/2, and then from 5/2 to 3 we're going up to. So keep in mind that g prime is 2 plus f of x. So when f of x, or when we're looking at x less than 5/2, if we take f of x and add 2, g of x on this interval, or g prime of x, would be positive. everything would be above the x-axis. So g prime is greater than 0. But when x is greater than 5/2, f of x plus 2 will still be under the x-axis, so g prime of x would be negative. So since our derivative is going from positive to negative at x equals 5/2, we can say that g has an absolute at x equals 5/2. All right, now for part C. Part C, we want to know where between -4 and 3 our graph of g has a point of inflection, and we have to give a reason. Now g will have a point of inflection when g double prime changes sign. Now let's come back over here. We know what g prime is equal to. Remember, g prime is 2 plus f of x. So g double prime is equal to f prime of x. So if we want to know where g double prime changes sign, we need to take a look at where f prime changes sign. Now here's a graph of f. If f prime is changing sign, that means that our function f is changing from increasing to decreasing, or from decreasing to increasing. And now that only happens once at x equals 0. So we can say the graph of g has a point of inflection at x equals 0 because g double prime, which is really f prime, changes sign at x equals 0. Okay, one more part, part D. Find the average rate of change of f on the interval. Okay, so our average rate of change, our interval is -4 to 3. So average rate of change would be f of 3 minus f of 4, f of -4, over 3 minus -4. So we need f of 3 and f of -4. F of 3 is -3, and f of -4 is -1. So we have -3 minus -1 over 7, which is 2/7. So the average value, or the average rate of change of f, is 2/7. Now they say that there is no point on the interval for which f prime is equal to the average rate of change. So that's the mean value theorem. The mean value theorem talks about the slope of the secant being equal to the slope of the tangent, but that only happens if our function is continuous and differentiable on the interval. And if we look at our function f from -4 to 3, there are actually two places where our function is not differentiable. One place is here, where we've got a vertical tangent line, and here, where the derivative from the left will not be equal to the derivative from the right. So we can say this does not contradict the mean value theorem, because f is not differentiable on our interval. And we're specifically looking at x equals -3 and x equals 0.